Hello my dear viewers, today we are going to study about acids, bases and indicators as our main topic, and your presenter and teacher is Namiiro and from Trinity College, Nabingo. We begin by looking at acids. We have heard about acids before probably. We have tested acids. We have found maybe acids in our environment, but probably we have not taken interest to find out what an acid is. Maybe we have not taken interest to find out what is contained in an acid, and today that is what we have come to discuss. An acid, we say, is a substance which when dissolved in water produces hydrogen ions as the only positively charged ions. Now, in an acid, there are very many different ions. What is unique about an acid is that it contains very many hydrogen ions, okay? There are even other substances that also contain hydrogen ions as positively charged ions, but they are not the only ones, and that makes them to be non-acidic. So acidic substances, we say, contain very many hydrogen ions. Now, some are edible, some are not. But those that are edible, usually they have a sour, tangy taste. Now, like I said, in our daily life, we have acids that we have come across. For example, you have lemon. Lemon has citric acids. We have tomatoes. We have grapes. They have tartaric acid. We have milk. Milk has lactic acid. We have ants. In ants, these ones, they form what we call formic acid. We have apples, they have acid in them. We have vinegar with acetic acid, and these are not the only acidic substances that we use in daily life. There are even others. I have said that we can identify them from the fact that they have a sour, tangy taste. Now, in daily life, like I have said, we have ethanoic acid, which is found in vinegar and tomato juice. We have citric acid, which is found in citrus foods, actually, fruits also, like lemons, oranges, and grapefruit. We have lactic acid. Lactic acid is found in sour milk and yogurt, and in muscle during respiration. Then we have tartaric acid. This one is found in grapes. We have tannic acid found in tea and ants' bodies. We have formic acid. Then we have hydrochloric acid, normally that we find in our stomach juices. Now, we also have acids that are mainly in the laboratory, and these ones are referred to as mineral acids. Examples include hydrochloric acid. Now, I follow this with an equation because I want you to take note of what I talked about, the definition of an acid as having hydrogen ions as the only positively charged ions. Then we have sulfuric acid, whose equation of ionization you can see. Okay, sulfuric acid ionizes to give us hydrogen ions and sulfate ions. Then we have nitric acid, whose formula is that, and it ionizes to give us hydrogen ions and nitrate ions. So some of the laboratory acids that we have here, you're seeing sulfuric acid in a bottle there, and other acids in bottles. Now, when we are having an acid, It may be dilute or it may be concentrated. So we say that a dilute acid is simply a solution containing a small amount of acid dissolved in water. A solution, I hope you remember that it is a uniform mixture of a solvent and a solute. In this case, our solute will be the acid and the solvent is water. Okay? Then concentrated acids usually are solutions containing a large amount of acid dissolved in water. We keep in mind the fact that we are talking about a solution. A solution contains a solute and a solvent. A solvent is water and our solute is the acid in question. So here we have the concentrated acid, usually is in the bottle, as you can see there, and we are saying that when we are diluting, so when we are diluting the acid, you have a large amount of water and you're adding a little amount of the acid. When the acid is concentrated, you have just a small percentage of water. For example, you can see there sulfuric acid having 98% concentration, meaning if there is water, the water constitutes only 2%, so that makes the acid concentrated. Lastly, today, as in this subtopic acids, we are going to look at basicity of an acid. Now we say that basicity is the maximum number of hydrogen ions produced by a molecule of an acid. Remember the equations of ionization? As the acid ionizes, it produces hydrogen ions and a radical. So the number of hydrogen ions that will be produced by an acid is what we shall refer to as the basicity of the acid. For example, hydrochloric acid ionizes to form one hydrogen ion and we say 1 mole of hydrogen ions and 1 mole of chloride ions. Nitric acid, the same. Sulfuric acid will give us 2 hydrogen ions and a sulfate. Phosphoric acid, as you see, will give us 3 hydrogen ions and a phosphate. So the basicity of hydrochloric acid will be 1, that of nitric acid will be 1, that of sulfuric acid is 2, and that of phosphoric acid is 3. So here we are saying that when do we see the hydrogen ions? When are the hydrogen ions formed? The hydrogen ions are formed when the acid is dissolved in water. So until the acid reacts with water, we may not have the hydrogen ions. That is why I'm showing you the ionization equation under reaction with water. Okay? So this is just to explain what I've just been talking about more. That say hydrochloric acid ionizes to give you that 1 mole of hydrogen ions and 1 mole of chloride ions, and we say it is monobasic. Okay? If it is monobasic, it has a basicity of 1. Nitric acid is also monobasic because it ionizes to give you 1 mole of hydrogen ions and nitrate ions, and we also say it is monobasic. Then we have ethanoic acid, which ionizes to give you hydrogen ions and the ethanoate radical, and we also say it is monobasic because it gives us 1 mole of hydrogen ions. Then we have sulfuric acid, which ionizes to give us 2 moles of hydrogen ions or 2 hydrogen ions, okay? And the sulfate radical. And then we say it is dibasic. So its basicity is 2, okay? We say its basicity is 2, and the acid is said to be di-basic. Then lastly, you have phosphoric acid, which also ionizes to give us 3 moles of hydrogen ions and a phosphate radical. We say it is tri-basic because it has a basicity of 3. It gives us 3 moles of hydrogen ions. So in conclusion, today we have talked about the definition of an acid and we have named some examples of acids. Then we've looked at the difference between a concentrated and a dilute acid, which I don't want you to forget that when you're talking about concentrated and dilute, mainly we are talking about solutions having the acid as the solute and solvent as water. When you have a large amount of acid, we say the acid is concentrated. When you have a small amount of acid, it is dilute, and then the basicity of an acid. For more information, contact the link below. Please visit www.tricona.sc.ug/e-library. You will get more help. Until we meet again,